This is a Tsunami Holographic Shrimp. If you've seen any of my fishing videos, you know that my dad is the biggest holo shrimp fan in the entire world. He catches more speckled trout on this lure than anything else in his tackle box. But it has a simple flaw, and he drew up a fix for it and sent it to the company. Of course, they ignored him completely. So I took matters into my own hands. I had to learn blender modeling, mold making techniques, injection molding principles, so much. I'm Ted Tremonti, Making Angler, and this is the story of how I reverse engineered and improved a legendary fishing lure.
I stumbled on these by accident at Bass Pro. I was just looking for a shrimp and I saw that one. It was good enough. And then when I saw the performance, I said, I'm not buying any else. I discovered a treasure. The fluorescent tape embedded in the body. I think it mimics natural shrimp. The problem is that you get so many strikes, the weight pulls out of the shrimp. Where the hook is wrapped, it's pointed, so when you get a bite, it pulls through. If this was a flat front, it wouldn't be able to pull out as easy. It would have to pull the front of the shrimp off to get it to pull out. Yeah, I sent it to him and never heard from him. I even wrote a story about when Uncle Jason and I went. He caught nothing, and every cast I was getting bites.
I'm interested to know how many of you have a favorite fishing lure that has a problem you really wish the company would address. Let me know in the comments if you've got one like that. His fix seemed simple enough, but I had no idea what I was getting into. So first I had to brush up on my shrimp anatomy. The typical Tsunami Holographic Shrimp's about 3 inches long or so. Has relatively long and thin legs and antenna. The plastic seems pretty hard, and the tail doesn't wiggle very much on its own. The hook point comes out about 2/3 of the body. Point itself is probably about halfway. The eye of the hook comes out between the eyes and is pretty much all the way at the front. There's not much material here. The internal lead weight is pretty much in line with the center axis of the shrimp. The hook itself is somewhere around like a 1/0 hook, I would say. What gives it that holographic quality, there's this bit of tape wrapped around. It's not as thick as tape, it's more like cellophane, but it does have some sort of adhesive. Besides the weight design, I also thought the shrimp could be improved. The tail and legs have a tendency to rip off pretty quickly, and I want my shrimp tail to wag like a dog. I also knew that this was going to cost me some money. I had never used silicone before, I needed lead pouring equipment, and my resin 3D printer was busted. The cost didn't matter at the time because I just thought it would be sick to make my dad's vision a reality. So with all that in mind, it was time to get to work. I started with the core of the project, the improved weight. The challenge was to design a better internal weight that resists sliding out of the shrimp. My dad's idea was for the weight to have an enlarged, blunt face rather than a profile slim enough to squeeze through the plastic. I also decided to make the face conical rather than flat. This would allow plastic to flow in, putting even more material in the way to resist the weight. My first instinct was to print a model of my weight and stick it in some clay and make a silicone mold based off of that. I used up almost an entire bottle of overpriced silicone before I stumbled on a video from the Never Ending Project list showing the technique of printing the mold positive as a box and filling that with silicone. I'll put a link to his video in the description. In addition to using a hook you could easily find in the store, a key feature I really wanted to include would be the ability to reuse the existing Tsunami hooks that had fallen out of shrimp. So I printed the master in PLA, filled the 2 halves with silicone, and popped out a perfectly cured mold. With a brand new lead pot, I was able to use the lead from Tsunami hooks and fresh bar to cast the improved weight design onto the hooks. And with such fantastic results, I really started to believe I could pull this off. Of course, the weight is just one part of the lure. The weight has to actually be cast inside the plastic. So I scoured the internet for a free shrimp model, but the only things that I could find were cartoonish renderings and a couple of lure STLs for sale. Then I tried using my phone to make a 3D scan of the actual Tsunami shrimp, and that didn't work at all. I even tried casting the Tsunami shrimp in silicone, but it was just never going to be usable. I really only had one option left. blender. I had never used this kind of blender before. After a week-long shrimp-flavored nightmare of a 3D sculpting learning curve, I settled on this, which I think is pretty good for having no 3D art experience. I beefed up and shortened the legs and antenna in an effort to make them more robust. I also flattened out and enlarged the tail in an effort to keep it from tearing off, while also making it much more floppy. With a shrimp model in hand, I could create the actual mold for the lure. I positioned the weighted hooks inside the shrimp model to create the mold cavity. To minimize air pockets, I chose to orient the shrimp like this, injecting at the tail and adding an air vent at this pocket. This mold needs to be able to survive 350°F or 180°C plastic. This is where a professional operation would slap a chunk of aluminum on their CNC table. I, however, opted to 3D print this out of resin. Resin printers solidify the liquid material with UV light, as opposed to FDM printers like this one that use heat to soften the material and cool it to solidify. In the past, I've found that ABS-like resins are plenty capable of withstanding the heat from plastisol without warping. So I had the weighted hook and the shrimp worked out, but it's called the holographic shrimp for a reason, and a plain lead just won't do. My dad was very clear it had to shine. I assumed this kind of tape would be easy to find online. I was wrong. The first stuff I bought wasn't even adhesive. The next roll was tape, but it wasn't transparent. Third roll of tape looked different, but had the same result. Finally, I gambled on a listing of an assortment of crafting tapes that didn't have very good reviews. To my surprise, the shine and adhesive held up to multiple rounds of molten plastic. Now I had several colors of shine to choose from, and as a bonus, their width matched pretty closely to my weight. It was time to put it all together. I wrapped a piece of tape around a weight, placed the hook in the mold, heated up the plastisol, and shot my shot. Send it. Here we go. That's pretty good. A lot of meat where the hook comes out, so that should resist tearing. But look at that. Not budging at all. Now, if I'm being honest with myself and you, I needed what felt like countless prototypes, weeks of my time, and $800 to make that first shrimp. Also, a pretty severe first-degree burn. Don't take any chances with plastisol. But if you ask me, it wasn't about saving time or money. It was about solving a problem. And I still didn't know if that problem was solved. So I did some science and then some fishing. Over at my workbench, I tied up a tsunami shrimp in my vise to a ratchet with 80-pound braid. After a few cranks, the weight completely pulled out. I then did the same thing with my new shrimp, and after a few cranks, the entire shrimp slipped out. I couldn't crank by hand at that point, so I grabbed a wrench. A few more cranks, and the whole shrimp popped out of the vise. The plastic itself on the shrimp was tearing, but the weight itself still pretty firmly in place, which seemed like a result to me. If you thought that test was bad, be prepared for this. This is a bucket full of nastiest well water. The tsunami shrimp falls pretty quickly, doesn't move a whole bunch underwater. It's definitely twitchy. My shrimp falls a little slower, falls a little more belly first, a little more stably. I think the legs and the tail are a little squishier, and overall it's just kind of not as twitchy. Honestly, I think it's kind of a draw. All of that garage testing was pretty pointless when, at the end of the day, the shrimp just needed to catch a fish. So, it's time to give that a shot. Check this out. Yeah, buddy. How nice is that? Where are the birds? Several birds. It's probably just ladyfish. I think I missed a hit. Oh, big splash. There we go. Oh! I think it's a catfish. Oh!
Not.
What are you? Catfish. Okay, well,
Gross.
the custom shrimp catches catfish.
I hate their little whiskers.
Here, get the rod. It's just a baby.
Little guy. I'm gonna take a picture of what my phone's.
Okay, cooperate with me. Give me my shrimp. Yay. And I can see the grass. There we go.
Oh my god, that was quick.
Yep, I'm cracked.
Holy shit.
It's 4 feet and grass. That's really all you need. Catfish though. Yep. Okay, well this is a catfish machine at least. He's much better.
The font size on my Kindle. The water splashed it.
Come on, tire yourself out.
I watched it.
Oh my god, please. Oh, lost a leg. I wish I had gloves. Oh, there goes the tail. There we go. I mean, I think that's proof right there.
Yeah. My nails are very cute with the rod.
Oh! Lost him. It's probably another catfish. Right, so what does it take to make a shrimp? It takes blender, it takes CAD, it takes silicone, it takes lead, it takes plastisol, it takes 3D printer resin, it takes tape, it's a lot. And so I don't really blame anybody for wanting to just go to Walmart and pay $3 for a pack of these. But doing all that wasn't about saving money on fishing lures. It was about solving a problem, and I think that's what being a maker is all about, is solving problems, especially the problems that you yourself are experiencing. I'm not gonna say that my shrimp is perfect. There are still some design quirks that can be improved for sure. But with the fishing I've done with this shrimp so far, I would say my problem has been solved. I addressed my problem completely. The weight does not pull out of the shrimp anymore, no matter how hard I've been fishing it. The lure disintegrates first. And that's exactly what I wanted. And so that's why I find that maker skills are so valuable when it comes to angling. And that's kind of why I started making these videos, is to really show how making and angling go together. Fishing's kind of always been about using tools to make a task easier, right? If it wasn't, we'd still be catching fish with our hands. If you want to try modifying this shrimp lure that I've made in this video, I'm gonna have the files available in Onshape. Make it your own. So if you liked this video, if you found it informative, if it gave you any ideas, or even if it was just entertaining, maybe click that subscribe button. And there's a few other videos like this on my channel you can go ahead and watch too. If this heat wave ever lets up, I'm gonna get back out on the water, and I'll see you on the next one.